Hello everybody and welcome back to another video. In our last video we talked about a few commands, and if you'll notice I'm not in my Linux machine this time. I'm in my Windows machine, and I thought I might switch back and forth just to show the different environments and how they are kind of the same, even though you call Windows, Linux, and whatever. They're kind of the same. They kind of work the same. There's just like subtle differences that you might not be familiar with. So I figure most people are already on a Windows machine anyway. And so if I just demonstrated how these things are applicable to people running on a Windows operating system, that it's not so weird. In fact, you might have stumbled upon some of these things on accident, really. So again, everything's pretty much the same. I typically don't use desktop icons on either Linux or Windows or my Mac machine, really, because there's always a better way to do something, and you should always, as a programmer, you should always be thinking about what is the better way to do these things. So typically, I use just an application launcher, and you see this is the start menu. Windows has had a start menu for a while, and I think it might have always been part of Windows, at least in the graphical operating systems. Maybe not in DOS, they didn't have a start menu, but I remember back in Windows 95 and 98 they had a start menu. And they still do. And so the thing you can do is just type in the application you want. So if you want Chrome, there's Chrome. If you want your terminal, I have a specific terminal installed because the default one, as I had mentioned, is CMD. And I think even Windows 10 comes with PowerShell now. PowerShell is kind of like a superset of CMD. CMD was very limited. They didn't have piping of output between programs, whereas PowerShell does. It's still not POSIX compliant. It's a tool developed for Windows to use on Windows, and apparently recently they've created a cross-platform version, but really it should be where it is. And that's one thing about the Unix philosophy and being POSIX compliant, is a tool is built for a specific purpose and it does that thing. That's it. And that's how the Unix philosophy, it's a philosophy around the Unix environment that has developed, and it's just some core ideas about what programs should do, and we'll get into that in a later time when we start talking about cohesion and coupling of programs and how programs should operate, and on even a more fundamental level how functions in a program should talk to each other and operate, because again that's kind of a shared idea between just programming and how programs interact with each other. The way they share information is similar, and so we'll get into some of the paradigms about how they should do those things, who should know what and who should do what, and how those things talk to each other. Those are things we'll get into. So if you're on Windows, you probably don't have the Windows terminal, which is like the premier terminal environment for, I wouldn't even say premier. It's the most useful, I guess, the most featureful terminal available at the time. There's some other ones, but I don't typically use those. I'm either using CMD, PowerShell, or WSL, and we'll talk about WSL for a second, I guess. So WSL just is a hypervisor that is very. A hypervisor is just like a virtualized environment in which you can do programming. And I'm going to turn off my screen. I think it's just like a right click. So all this thing does is filter out some of the colors. And I'm going to turn it off because I can't tell if it's going to be recorded or not, and it helps me see some of this dark blue stuff. Anyway, this is some of the reason why I don't typically use this, but Windows Terminal kind of like just encapsulates this. You can see they're very similar, except this is much more readable. And doing things on here, you have to go into the properties. If I want the font to be bigger, I have to go in here and then make the font bigger and say okay. You can't just do Control plus or minus to change the font size in here. So I typically just use Windows Terminal. And if you're trying to get this, all you have to do is go to the shop or store. Yeah, the Windows Store. Yeah. And download it. And you can also download, while you're there, WSL. So WSL, as I said, is a hypervisor or a virtualized environment in which we can load the Linux terminal into it. And it can talk very well to the Windows environment that encapsulates it. It's developed by Windows, and Windows actually, or Microsoft actually is one of the top supporters of the Linux Foundation. They give them a lot of money, basically, to support them. And so you get a few perks with that. You get your own connections into the Linux kernel, I guess. And these things have allowed them to create a very tightly coupled, very integrated environment with, and it's not perfect because not everything that Linux can do, Windows can do, and not everything Windows can do, Linux can do. They don't talk 100%, but it's very close, and so close that it's pretty indistinguishable if you load the right distribution into this virtualized environment. So if you go into the Windows Store and you look for WSL, you'll get the distributions here, and you have to pick one. Each one is its own virtualized environment. So, and these ones that are in the Windows Store are the ones that Windows officially is working on. I don't know if you can load different ones besides the ones in the store into WSL, but I would suggest you just use these. And specifically, I suggest you either use Ubuntu or Debian. These two are very stable and very highly supported. Whereas if you go over to these other ones that have double-digit reviews, they're probably less supported. But again, I would suggest you either pick Ubuntu or Debian. Doesn't matter. Ubuntu is actually based on Debian, but it's just a little more worked on in its own way, because Debian is again very slow to adapt. So Debian runs on a lot of servers because it's very secure and it's very well tested. But that typically means that it's 5 to 10 years behind the bleeding edge, whereas the distribution I was using, Manjaro, is kind of like the same situation Ubuntu is with Debian. Manjaro is based on a distro called Arch Linux, which is a rolling release version. So, and it's also very heavily supported by the community around it, in that they can create their own packages and put them in what's called the Arch users repositories, and you can download them and install them really easy. It's really easy to install packages, remove packages, roll back packages inside of Arch. But that might not necessarily be the case for Debian, because some things could break other things. Things that are really dependent on each other, they don't work well in Debian because of this dependency issue. And Arch has that down really well. But some updates can still break other things. But it's easier to roll back things in Arch than it is in Debian. So the one I use is Ubuntu, just because it might actually be this one. But the one I use is Ubuntu. I learned everything I know on Debian, actually, in regards to Linux and Unix in general. I learned everything on Debian. And we can go into why later if anybody cares, but I'm just going to gloss over. This is the one I learned on, but this is the one I use inside of WSL. So after you get everything installed you need from the Windows Store, that being the Windows terminal if you choose to use it, and your distribution, you have to do a few more things in order to get WSL to work on your Windows 10 system. You have to run a few commands in PowerShell in order to turn it on, because I don't know why it's not turned on by default. So if you're working in a build that is either higher or equal to 2026.2, then you can just type WSL tac install. Otherwise, you're going to have to run some commands in the PowerShell manually. But at the end of following this document, you're going to have to restart your system regardless. You can find this document on MSDN, which is the Microsoft Software Developers Network. It's just the documentation for your Windows operating system and how you can program on it. This will be a very valuable resource if you choose to develop programs on Microsoft. But all you have to do is open PowerShell, and if you don't have PowerShell, I believe that it's installed by default on any recent version of Windows 10. Otherwise, you might have to download and install it somewhere. So if you're working on that build, just WSL install. Otherwise, you have to run a few commands, and you can just copy and paste directly into PowerShell and then hit enter. It's just like a terminal. Copy paste. All this does is enables WSL and downloads some stuff. Make sure that it's installed, and if you have multiple distros, you have to set the default version for WSL like this. This number designates which distribution to load, or this is for the version of WSL. You can do some stuff for setting up which distribution is the default if you have multiple. I think I only have Ubuntu on here. We can go back and look. You can see this is me running some commands. Okay, it looks like tag T designates which one is the default. So we can do tag T and then Okay, so if you type in PowerShell WSL tag help, you'll get what looks similar to a man page, and it is pretty similar to a man page. It's almost indistinguishable, but it's not necessarily a man page. The reason they look like this is because they were written in a really, really old programming language that was meant for being printed, and so they all look similar to this if they followed with that programming language. And you can see what you can do if you type the WSL command into PowerShell. None of this is relevant to anything we're doing right now. If you follow along with this, you will then have, it even has a section about setting up and installing Windows Terminal. If you just follow it, you'll end up with a similar system as this. And this can be configured as well with this drop down. You go to settings, and it's written in a language or in a format called JavaScript object notation. That's neither here nor there. And that, in fact, I might discuss maybe at the end of this video what we'll be doing in future videos. So you'll have this, if you click this drop down, you can select any of these. So this is your WSL, distribution, command, CMD, and PowerShell. This is Azure Cloud, which is like a container. Thinking about, so it's similar to Docker or Kubernetes. They operate on containers, which are just like little like virtualized environments. Almost, they're very, 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 very similar to hypervisors like this, except they have their own. You're not meant to directly interact with them. They're meant to be like self-contained, and then you send them information, and then they work on that however they're designed to work on it. Maybe we can talk about like containers and the differences between containers and virtual machines and stuff like that. They're really similar, but they have just nuanced differences in how they operate and how they're used. So I'm going to open up command prompts. Everybody has command prompt. Not everybody has PowerShell, depending on what version of Windows you're using, but if you're using a modern one, you probably have PowerShell. But these commands work in CMD as well. And I'll be demonstrating how to do some of the things I'm going to be showing you here in the Windows, or in the Windows terminal for Debian, or not Debian, Ubuntu. This is Ubuntu. You can check. Oh, NeoFetch is not installed. Anyway, I guarantee that this is Ubuntu that is running in here. So we talked about man, ls, cat, echo, vim, your editor, change directory, print working directory, cat. Oh, I already wrote cat. Anyway, we covered a lot. Apropos, that's another one. We're going to cover a lot of commands. And some that I didn't mention that I'll have to introduce in order for us to do some more of what we're going to be doing today are how to remove a file with rm. There's also rmdir. The caveat for rmdir, it removes a directory, but it has to be completely empty. Maybe there's some flags for making it work with things that aren't empty, but remove can also remove directories. You just have to pass the flag tac-r, which tells it to recursively remove. So it won't matter if there's files in that directory or not. It'll remove them. And in fact, rmtag-d is equivalent to remove directory. They work exactly the same. So I'm going to tend to use remove more than remove directory. For that matter, we also would need to know how to make a directory in the first place. You can do that with make directory, mkdir. You just pass to it the name of the file that you're wanting to make. So if you type mkdir testdir and you type ls, you can now see there's testdir. If I remove testdir, again, you have to add the tac-r to. Let me show you that if I didn't do that, it would complain about it. See, is a directory. So you can either do tac R, and in this case you can do tac D because tester is completely empty. We also need to know how to make a file. We can make a directory, but how do we make a file? I said that you could use vim to edit a file, and if you just type vim, it opens a file that is empty. Like there's no name. It has no name. It doesn't know what it has in it, and you can type in here whatever you want. But if you wanted to save it, you have to give it a name. So let's call this a file. You don't even need to tell it what format it is. It'll just say, okay, I wrote to whatever that is. Now you can see that a file is there. If you tried to open a file in your system and it doesn't have the format specifier at the end of it, it'll ask you, well, I don't know what this is, what do you want to open it with? So if you tried to open it in Windows, we can go to, this is one of the cool things about being in WSL. I can call cmd.exe from here, and then if you hit enter, it changes your prompt. Just like if you're doing from zish to bash to sh, it'll do the same thing. Now I can run programs that are part of Windows and not part of Linux here. You can also do it the other way around for WSL. If I call it WSL, I get back in here. Cool thing though, I can tell it to run WSL and then a command. See, a file. So I don't necessarily even have to log into WSL or CMD for that matter. You can pass them, and you can do the same thing on. You can do the same thing for bash and zish and stuff. You can send it a command and it'll return the response instead of logging into that shell. So dir gives you the directory, and I told you dir looked a little different than ls. So whenever I type ls, it gives me stuff like just the files. This gives me more information than I asked for, but it's fine, whatever. You can see a file here. But we don't have cat in CMD. We have type, a file. And that'll show what's inside. But if we go to PowerShell, let me exit out of this. And if we go to PowerShell.exe, again, none of these things work, but they don't work flawlessly because they don't function the same way. Windows and Unix, the way they do things is different, so you'll have issues. And even with this terminal, it's not like 100% certain that it's always going to work. So now we're in PowerShell. You can see that it's denoted with PS in front of it. We can do things like cat a file because cat is an alias for dir for type. You can do cat, and this is how you okay. So CMD doesn't have the man pages. I know I showed you what looked like a man page. It's not necessarily a man page. It was the help. So if I do CD, this gives you, I don't know what's with this red text or why it's filling out in red. In fact, I might just open CMD here so that I can further emphasize this and make it bigger. So this is just CMD. I don't have Windows Terminal. It's not wrapped in Windows Terminal, so I won't get any of this red text stuff. So if I did CD and I did / ? that gives you the help, essentially what tac help was doing. Except it's not in CMD, it's only in PowerShell. But this is the help that you'll see. And this is how it's kind of like asking for the tac help. But that's not here. You'd have to go to PowerShell in order for that to be a thing. So here's cat. See, it doesn't, I don't know why this flag typing doesn't work here. But if you do cat tac help, is man cat here? So it does have a man. PowerShell has a man function, but this should get you exactly the same information that you got here, except it's relevant to PowerShell. If I were telling you to learn one of these things, it would probably be PowerShell, because it's more featureful and you can do things like piping output around, but CMD doesn't work that way. And I think the discoverability for CMD is probably much worse than the discoverability of PowerShell. In CMD, you do have a help. If you just type help, this gives you all the commands that are system, like built into the system. And if you're going to be doing scripting in CMD, these are the commands you would use. You have CD, you have copy, date, display or set the date. You also have find, the find command that I mentioned, but these don't work exactly the same in this system as they do on Unix or even in PowerShell. They work differently. So making a directory is the same, I believe. So you should have mkdir, yeah, right here. Create a directory. There's a shortening, MD. These things are not always intuitive, but for our purposes, we're only interested in how you would make it, make a directory. So you also have a way of making files, which is touch. You can also echo whatever you want, even nothing, and then do 2 greater than symbols, and then type the name. So if I said echo, you can even do 1. This gets into piping, so piping looks like that, like this, and like this. These 4 symbols all mean something specific in the Unix scripting shells for taking the output of one thing and then moving it somewhere else. So we had echo and then hello. That's what we're doing. But if I say echo hello to a file .text, it doesn't matter. Now you see that it doesn't show up. That's because it was written into a file called a file.txt. And we have 2 of those, but the one we made is this one. So if you cat a file.txt, you'll see it says hello. Now we can do that without, and this is just asterisk is a wild card for selecting everything. That's all that means. So I removed everything is gone. So if we decided to echo, but we didn't supply it with a string to echo a file.txt, you can see it still makes a file, but if we cat it, there's nothing inside. Absolutely nothing. In fact, if I do ls tac l, you can see there's 1 byte that was written to it. If you're trying to make a completely empty file, you could use the command touch. All touch does is updates the timestamp of the file. So the last time it was changed, the last time you change a file, it updates the timestamp, and that's all this does. It doesn't change anything about the file. But if you do touch b file, this will create the file B file and update its timestamp. And the difference between these are that one had to have at least a 1 byte written to it, which is probably the new line character, which is why there's a space here. And this one doesn't have any. So if we cat both of these, a file and B file, you can see they're both empty. But if we only cat B file, we won't get this new line here, because that's the character that's written in A file. You can go vim A file. And I believe if we delete it like that, and then we list it, now they're both 0. Because that's why I had weird characters inside my vim, so I can see these white space characters that you can't normally see. They don't represent text that will appear, but it's white space, like a space or tab. New lines, they're all white space characters that you can't perceive. They just represent something to the way the text is oriented. So now that we have a way to create files and directories, now we can finally get started. But I think we've been going long enough, and I'm going to introduce one more command, and that is node. Node is kind of like Python, except it's an interpreter for a different language, and that is JavaScript, which is not the same as Python. JavaScript is a language that was developed for operating on the document object model, which is a fancy way of saying it affects how web pages look, or what they do. It was an object-oriented language that was developed in a week. The standard was written in a week. This has led to a lot of weird, clunky things in vanilla JavaScript, and a lot of people prefer the newer iterations on JavaScript, such as ECMAScript 6 and TypeScript, which is a version of JavaScript that has more strict enforcement of what types of data you're using. Whereas with Python and with JavaScript, vanilla JavaScript, those typing requirements aren't strictly enforced, and you can do whatever you want. So again, we have things like printing, but for printing in JavaScript, you log to console whatever string you want, hello, and it'll print hello. Now the cool thing about this is that you could also do it in your browser. So if I open this browser, it just had this page, and it doesn't really matter what page you're on. If you hit, I think it's F12, yeah, F12, it'll load this thing, this weird thing. And this works for Chrome as well. I don't know if it's F12 in Chrome, but this is called your developer tools. If you go to view, I think. Oh no, okay, so you have tools and then web developer, and then you can just do toggle tools. Inspector is what this is. We specifically want the console. You can just trash all this, and you can still do this stuff. Console.log hello, and you'll get hello again. So see that these are like the same. So your web browser basically is a really complicated version of what Node is. And Node.js is something that isn't going to be installed on your system by default. You're going to have to install it. And if you're on Windows, you can just go to Node.js and install it. Or you can use a package manager like I do. So Node on Windows works pretty much the same. Node. Did I not install it? Anyway, the way you install it is you type, or you have to download this to either the Scoop package manager or the Chocolatey package manager on Windows. So if you go to Scoop, Scoop is specifically for terminal stuff. It doesn't have like graphical applications installed. So all you gotta do is run this script in your PowerShell, and then you'll have Scoop installed. So if I type Scoop install Node.js, it'll install Node. But if you're on Linux, your distribution more likely than not has a package manager that goes with it. For Ubuntu, it's it's actually dpkg. That's the actual one. And then there's a wrapper for that is apt-get. And then there's a better one called apt, and then the one I use, which handles all that dependency crap that I talked about earlier, which is aptitude. So I use aptitude. You can choose to use any of these. Apt supports the installing of dependencies better than apt-get does, and I don't know anybody that uses dpkg personally. I choose to use aptitude just because it works for me. And I'll have to talk about one more command, which is sudo, or super user do. This just is the same as telling Ubuntu, or if you're in Windows and you go to I don't know, here's VS Code in here. If you right click on it, you can you tell it to okay. I am specifically looking for, I'll just go here. So this is the Windows Terminal application that I have pinned to my taskbar. If you right click on it, you get all this stuff. Now this is some stuff that I don't know why it's so difficult to find these things on Windows, but if you right click on Windows Terminal in this drop down, you get another menu that says what do you want to do, and you have to run it as an administrator in order to do some stuff with elevated privilege other than a user's privilege. So this is like something that a system administrator would be doing. And that's why it's called sudo, super user do. Sudo allows you to elevate the privileges of the command you're going to run. But it also requires an administrative password. And if you're the only person on your system, that's usually your password is the administrative password. So in order to use aptitude, I have to do sudo aptitude install. And then I would say node. I already have node installed. I just demonstrated the program. But if you are just getting started, you have to install it. And this is how, even aptitude, you have to install. So if you're on Ubuntu, you have apt-get. That's your default. And so you'd say apt-get install node. And you can designate more packages after the install portion. So if you want to install node, install neovim, or nvim, I think. If you're on Ubuntu, you can even designate like whole packages like Firefox. Or these are graphical, whereas these ones are from the terminal specifically. You can install Firefox this way. You can install GIMP this way. You can install VS Code this way. You'd have to look up specifically what the package name is, and you can use search. In fact, we can just do man apt-get. And usually with package managers, it's very monolithic. So you can reinstall, you can clean, which removes broken packages. download binaries. So if there are binaries hosted somewhere, and the thing about this package manager is that it's not anybody can contribute to the package manager's repositories, like on Arch you can. They're usually reviewed and they're very heavily scrutinized. And here's dpkg. So you can see that apt is just something that extends dpkg. But usually I just install aptitude with apt, and after that you can use aptitude. So you have to do sudo apt get install aptitude, and then you put your password in, and you can see that it's already installed, but I don't know if there's a small package I can uninstall and then reinstall. Anyway, that's how you install packages. That's not what we're trying to get to. We're trying to get to actually programming. But this is useful if you're trying to install things instead of having to go to the internet every time. You can just use a package manager and it handles installation for you. So now we have Node.js installed in the actual CMD terminal. So now we should just be able to type node. Very odd. I think it's installed to a specific spot that the terminal can't see, which is, so this gets into a thing called, there's another environmental thing called the path. You have this on Linux as well. So if you echo the path variable, you can see all these directories that are sourcing to the path. So anywhere in here, anything in any of these directories, we can run directly, okay? Because we basically have eyes that look at all these directories. So if I say ls, ls tacl, we can see there's nothing in here. But if we had a path that told us, hey, go look at my home directory, so $home, we can see there's something called docs in home, but we didn't change our directory to look at this. And that's kind of how path works. If we're trying to run a program that's in any of these, in fact, if you do where ls, which ls, my bad. You can see it's in something user bin is where it's located. And you can see that if we go through this, we can see right here, that's where user bin is. So that's where ls lives, is in this directory. And the only reason we can just call it like this is because we have eyes into this directory with this path. But whenever it's installed, it probably installed it into a directory that we couldn't directly see. And you can see that it's trying to link stuff here. So scoop apps node.js 1540. I'm betting that somewhere in this directory is the node program. So if we cd to home or whatever, this scoop, where is it putting this? Should just be able to say node and it run. Node is not recognized as an internal or external command. Interesting. Well, this is how you would install packages, and I'll go over how to fix something like this, because again, the path for CMD is a little different than how you would set the path for a Linux machine. In this, all you'd have to do is say path equals $ path, and all of these directories are delimited with a semicolon, or just a colon, and then you can type whatever you want afterwards. So these have to, this is a string, so it has to be surrounded with double quotes and then new directory. If I do that and then I echo path again, you can see that new directory is the very last directory that was assigned here. And again, if you're a brand new person, this is probably really freaking complicated. And I've given you a lot to think about already. So we might just drop it, and if you're doing stuff with JavaScript and you don't want to go through all this Node stuff, you can just go to those tools I showed you and then click on console. I can show you in Chrome real quick too. So if you go to Chrome and then you click, or you press F12 again, it'll pull up the developer tools, and again, it's just console, and it's the exact same thing. So console.log hello. So you can do your JavaScript stuff in your browser. You don't have to download this stuff and set it up. Node is a little more complicated than really you need anyway, because it includes a bunch of stuff like a server and a really complicated workflow that if you're trying to use it with other programs, it's probably a little further from what you're going to be wanting, like a debugger and being able to look at the memory and look at the source code. So this is actual code right here for the sign-in view of your whatever page this is. And this is what JavaScript actually looks like. These are all functions. This is how a web page looks with HTML. And these are outside files that are being included inside this file. And we'll talk about how to do all these things. Now, one thing I pondered to myself, and I guess this will be my closing statements, one thing I pondered to myself is, what do I want to do with this? What do I actually want to accomplish with this series? We've got everything, we've got literally everything we need. We can make files, delete files, change directories, make directories, write text to files, and start the interpreters we'll need, which are Python and Node. And again, if you're doing JavaScript stuff and you don't want to set up Node, you can just open up the console. But what do we want to do? With Python, it's a general purpose language that you can do a lot of things with, but it's not specifically very good at anything. But it's very easy to use. You wouldn't write a video game in Python. You just wouldn't do it. You wouldn't write a web page in Python. You can probably set it up to where you could just write Python stuff and it would work. But though, again, with the Unix philosophy, there's a specific purpose. And again, what I would say Python is good for is a little bit of everything, but it's not specifically good at anything. So what I would use Python for would be like prototyping or setting up an idea. It's very simple to write, so it gets out of the way. But if you're trying to do low-level programming, you would probably use a different language. If you're trying to do web programming, you'll use a different language. But Python is a good spot to teach because it covers all the basics. But Node is also good at that. Again, barely distinguishable between these two things. And but Node is a little more useful in that it's used. I just showed you it's used on web. You can write web pages with it. You can write applications for web on it, specifically on Node. So I'm gonna think more and ponder which one of these two I'll show first. I'll probably end up showing both of them, but whether you should pick a language for making something that you want, not to pick to learn. So if you don't want to learn to program in a vacuum just because you want to make something, so I'm gonna come up with something to make, and I'll think about whether or not it would be best to do that in Python or in JavaScript, and then we'll go from there. So thank you for watching, and have a good night, and catch me in the next one later.